second half of your Geometry Semester 2 final review. Starting on number 17, we have a setup of two secants meeting at an outside point on a circle. And here on my formula sheet is my setup. So I've got A and B and C and D. So A and B are on the same line. C and D are on the same line. I'm sorry, A and B are here and C and D are here. So I'm going to go back to my example and mark them this way. So this will become my A and my B and my C and my D. And in order to solve for X, I am going to follow the setup that I see right here. So A times A plus B equals C times C plus D. Now I'm just going to fill in what I've got. A is 8, open parentheses, A is still 8, plus B, which is 12, equals C, which is 6, open parentheses, C is still 6, plus D is my X. All right. I'm going to do a little cleanup. Okay. 8 times 20. Let's see what 8 times 20 is. 8 times 20, 160. And 6 times 6 is 36. And 6 times positive X is plus 6X. Okay? Don't forget that distributive property. So now I'm going to keep my variables on this side, my constants on this side. So I'm going to subtract 36 from both sides, leaving me 6X. And 160 minus 36, 124. Divide both sides by 6. And I get a funky looking fraction. So let's put that in decimal form. 20.67. X equals 20.67. You don't have a unit of measure, but X is a length, so it is in units. I was asked to solve for X. I have solved for X, put a box around it, and we go on to the next one. 18, given the diagram below, solve for X. X is over here. And this setup, looks like this. Okay, so I've got A times B equals C times D. A and B are on the same line. C and D are on the same line. So I'm going to take this setup and go and mark my problem. And I'm going to call this line AB. So those numbers on the same line. That makes CD on the other line. And the setup is A times B equals C times D. Now I'm going to go back and plug in what I've got. A is 6 times B, which is 13, equals C, which is my X, times D, which is 3. Okay, 6 times 13, 78. 8 times, X times 3, 3X. So I'm going to divide both sides by 3. Put a decimal this time, and get 26. So 26, we got inches, I remembered my unit of measure, equals X. I have solved for X. I have my unit of measure. I am good to go on. Whee! All right, number 19. Solve for X in the special right triangle. I've got 90 degrees here, 45 degrees here. That leaves this angle to be a 45-degree angle. And our special right triangles for 45, 45, 90 are that across from my 45-degree angle is a building block, Across from the other 45-degree angle is the same measure. And across from my 90-degree angle is my building block times the square root of 2. So let's see what we've got. Excuse me. 45 degrees across is currently an x. Write that down. I need to solve for that. Across from this 45-degree angle, I got nothing. All right, leaving it blank. Across from my 90-degree angle is 16, and that causes me that square root of 2 problem. Something times the square root of 2 equals 16. Something times the square root of 2 equals 16. And I've already shown you the 2 ways that we can deal with this. And frankly, I still like the one that the guy in the video showed us. I need something times the square root of 2 to equal 16. And the easiest way to get rid of that square root of 2 is to multiply it by the square root of 2. This will fall out as 2. So something times 2 is 16. That something is 8. So my building block is 8 times the square root of 2. Well, I'm going to take that back over here. My building block is 8 times the square root of 2. I don't have a unit of measure, so it's in units. So my x equals 8 square roots of 2 units for that special right triangle. Okay? Let me know if you want some more practice with this. Okay? I'll show you the other way. It's a little less fill in the blank, but a little more algebra. So you guys let me know what you need. Okay, number 20. Number 20. Oh, I know we're not done. Where is the next section for me to work on? Okay, I found it. Number 20, solve for A. Here's my A. I once again have a 90-degree angle, a 60-degree angle. That leaves this angle to be 30. I have a 30, 60, 90 right triangle. You remember the rules for our 30, 60, 90. Across from 30 degrees is our building block. Across from our 60-degree angle is our building block times the square root of 3. And across from our right angle is 2 times our building block. So let's see what we've got. Across from my 30-degree angle, woohoo, I have information. That building block is 8. Across from my 60-degree angle, I've got nothing, so I don't really mind. And across from my 90-degree angle is my A. So 2 times my building block of 8 is 16. A is a length. That is my unit of measure. I don't have one, call it units. So 16 units is the side length of that right triangle. This is units. Better. Okay. 21. Find the area of circle Q in terms of pi. So I'm not going to multiply out pi. The area equation is pi radius squared. And how did I know that? Well, I went to my formula chart and I found that. Where did I find it? Area, down here in circles, pi times radius squared. Okay, this whole line is the diameter. I want from the center to the edge, that is my radius. And remember that a diameter is just 2 radii, so my radius is half my diameter. So my diameter is 9 inches, half of 18. So now I have all of the pieces that I need in order to fill it in. Pi times 9 squared. 9 times 9 is 81. pi, because I want it in terms of pi. So pi needs to be part of my answer. I'm not going to multiply it out. I have a unit of measure this time. It is inches. And we square area answers. So 81 pi inches squared is the area of this circle in terms of pi. Number 22, find the area of a regular pentagon with an apothem of 4 and a side of 6. Well, remember that our area for any regular polygon is apothem times perimeter divided by 2. I've got an apothem and I've got a side. And perimeter is a walk around the edge of the shape. A pentagon has 5 sides. So if each side is 6, and I got 5 of them, my perimeter is 30. I write that down. Perimeter is 30. My apothem is given to me as 4. I have all of the pieces I need to fill in this equation. So 4 times 30 divided by 2 is going to give me the area of that pentagon. And 120 divided by 2 is going to give me 60. I don't have a unit of measure, so I'm going to go with 60 units. And it's area, so I've got to square it. But, you know, Miss Hart sometimes can't actually do math in her head, so 4 times 30 divided by 2 is 60. All right. Calculated. Boxed. Ready to move on. 23. This one I want to find the apothem from the center to the side. Okay? For a regular hexagon with a side length of 4 meters, and we're going to round it to the nearest tenth. Okay. First of all, let's draw a hexagon. Hexagon has 6 sides. So it looks something like that. Our apothem is from the center to the side, making a right angle and cutting that side in half. It is a perpendicular bisector. I'm told that my side length is 4 meters. And now I have to draw in a radius, because that'll give me a right triangle. I'm going to pull that right triangle out a little bit, make it bigger so we can work with it. Here's my right angle. This side is also 4 and 4 and 4 and 4 and 4. So this half of that side is going to be 2 meters. And I need to find the apothem, where that is my x. Okay? All right. Now this is what I got to find. This is the information I have. I can figure out something else. I can figure out an angle measure. And I do that by taking the sum of interior angles of a 6-sided figure minus 2. Do that first and then multiply it by 180. So 4 times 180 is 720. And I'm going to divide it by the 6 angles that I have. So each angle in my regular hexagon, remember, regular means all sides are congruent and all angles are congruent, is 120. So this angle is 120. So is that one and that one and that one and that one and that one. But I've got this radius as an angle bisector. So I'm going to take half of that angle measure. Okay. Now I have 90 degrees, 60 degrees. That leaves me with 30, 60, 90 right triangle again. And we just did some of those back up on number 20. Okay. So across from our 30 degrees is our building block. Our building block is 2. Across from 60 degrees is our building block of 2 times the square root of 3. Well, shoot, that's my apothem. That's exactly what I was looking for. So I'm going to say that my apothem equals 2 square roots of 3 meters, and it's not squared because this is a length. Okay? From the center to the edge, that apothem is 2 times the square root of 3 meters. All right, number 24. This time we've got to find the area of the regular polygon, and it's a triangle. So again, our area equation for any regular polygon is apothem times perimeter divided by 2. I've got the apothem. Cool. I need the perimeter. I need to know how far it is around this shape. I'm not really going to do anything different than I did in 23. I'm going to draw in a radius. From the center to a vertex is a radius, creating a right angle. And I need to find an angle measure to help me out. Well, we know that triangles, the sum of the interior angles of a triangle, are all 180. I need to divvy it up amongst these 3 angles evenly, so I'm going to divide it by 3. And each angle is 60 degrees. That radius bisects that angle, so I am going to take half of it as part of my right triangle. Now I'm going to pull it out and make it a little bigger so that we can work with it. This side is 12. Here's my right angle. I have a 30, 60, 90 degree triangle. Oh, I got lucky again. My building block is 12. But remember, the part I want to really know about is here. Okay? So this is what I'm looking for. And across from my 60-degree angle is my building block, in this case 12, times the square root of 3. So if I data transfer that back over here, I get samesies on each side. And if I add those together, each of my sides is 24 times the square root of 3. Okay, so 24 plus 24 plus 24 gives me 72. So perimeter equals 72 square roots of 3. And frankly, if you don't believe me, that's okay. Let's see what our calculator says. 24 times the square root of 3 gives me 4156. .692. That's one side. I'm going to multiply it by 3 and get 124.708. Okay. This is what I think our perimeter is. Let's see if this perimeter number gives me that number when I do the math out. Okay. 72 times the square root of 3. Oh, I get the same answer. These are equivalent. Okay. So 72 square roots of 3 is my perimeter. My apothem I already have been given as 12. So I have everything I need to fill in my equation. So 12 times 72 times the square root of 3 divided by 2. I'm going to go ahead and reduce this early and say 6 times 72 times the square root of 3 equals 72 times 6, 432 square roots of 3. I do not have any units, so that is units. Squared because it's area. Oh, but I was asked to round my answer to the nearest tenth. Okay, this time I'm going to go ahead and multiply out the 432 times the square root of 3. All right, 432 times the square root of 3 gives me a final answer of approximately 748.25 units squared. So either way that you are presented in your multiple choice answer, you can answer it in the radical form, square root of 3, or in the approximate decimal form. Okay? All right, turning the page to number 25. 25 asks us to find the area of the composite figure. Okay, so let's look at the shapes we have. We have a rectangle, and I know that a rectangle is length times width, so I'm going to say that this is 14 times 18. 14 here, 18 here, we're good. Now, I also have this triangle that's got a height of 10 and a base of 18. Now, then the area of a triangle is base times height divided by 2. So in our case, our base will be 18. Our height is going to be 10. We're going to take all of that and divide it by 2. But Ms. Hart, we have the exact same one over here. Okay, well, let's take the same two triangles and say, whatever that area is, we need it times 2. Which will allow me to do this and cancel out those 2's. And the area of that triangle then is 18 times 10, or 180. But don't forget, I haven't done the area of this rectangle. So the area of the rectangle is length times width, 14 times 18. And I don't know what 14 times 18 is, so I'm going to put it in my calculator and get 252. And I am going to add these together because I want the entire area. So 252 plus 180 equals 432. I have a unit of measure in feet. It is area, so we square it. I am just going to put a box around that and go along to the next one. Number 6, what is the area of the unshaded part? Okay. So I know it didn't come across very well, but this is shaded and this is shaded, and I've got a big rectangle. Okay. So the area of the big rectangle is going to be length times width, 300 times 175. And then I'm going to subtract off this shaded part. Now that shaded part is marked as a square. So the area of the square is going to be 120 times 120, and I am going to subtract that. Okay? So I'm going to make myself a note out here. Subtract the area of the square. My other shaded part is the area of a triangle. And that is going to be length, base times height divided by 2. So 150 times 175 divided by 2 is going to be the area that I'm going to subtract from the rest of the rectangle. So now I've got the math part to do. 300 times 175 gives me 52,500. Okay, 120 squared is going to give me 14,400. And 150 times 175 divided by 2 is 13,125. Remember to subtract these two. So 5,500 minus 1,400 minus 1,3,125 equals 24,975. Unit of measure feet. Squared because it's area. And that is the unshaded part of that rectangle. Okay, number 27. Find the volume of a cylinder. I don't remember how to find the volume of the cylinder, Miss Hart. Well, cylinder, volume. It is on your formula sheet. So the volume of a cylinder equals pi radius squared times height. Okay? Let's see. So this is my diameter, and I need radius. So from the center to the edge, it's going to be half of that. So 7.4, and my height is 12. Okay? I have all the pieces I need to fill this in. So pi times 7.4, the radius, squared, times the height of 12, and 7.4 squared times 12, I get 657.12 pi, and I don't have a unit of measure, but it is cubed for volume. Now, you may have to multiply out pi, okay? So if you get numbers bigger than this on your answer sheet or on your available answers, that's all it means, is you're going to multiply it by 3.1415. And your next answer is 2064.34 units cubed. Okay? So it depends on whether you're asked for the answer in terms of pi or as a complete decimal. Okay? But both of these answers are correct. It's just a matter of which format your test answer wants them in. All right, next one. Find the volume of the sphere. Back to my formula sheet. Sphere volume. Volume of sphere equals 4/3 pi radius cubed. So the only thing I need is the radius, and I'm given the diameter. So once again, from the center to the edge is my radius. It is half of my diameter. So 12 meters is my radius. And that's the only thing I needed to be able to go and fill in my equation. So 4/3 times pi times 12 to the third power. Remember, that's 12 times 12 times 12. And I get 1728. I haven't done anything with 4/3, and I haven't done anything with pi. So the next thing I'm going to do is multiply that answer times 4, and then divide it by 3 for that 4/3, and get 2304 pi meters cubed, because it's area, or I'm sorry, volume, or I can also take 2304 and multiply it by pi, 3.1415, and get an approximate answer of 7238.02, still meters cubed. Okay? So again, it depends on what your answer choices are as to leaving it in terms of pi or multiplying out pi. Okay. Oh, we are so close to being done. 29. Find the surface area of the cone. Okay, back to my formula sheet. Cone, total surface area. I'm going to write that down. Surface area of the cone is pi radius squared plus pi r L. Now remember that L is not length, that is slant height. Okay? So it's that slanted part of the cone. And here, 13.6 kilometers is our slant height. So why don't we go ahead and put that as L. Now I need a radius. And once again, I have a diameter. So from the center to the edge is half. So 7.5 kilometers is half of 15 kilometers. I have my radius, I have my slant height, got everything I need to fill in my equation. All right, so pi times the radius, 7.5 squared, plus pi times the radius, still 7.5, times the slant height of 13.6. All right, I can do some calculations now. 7.5 squared is 56.25. Haven't done anything with pi, it is still being multiplied. Plus 7.5 times 13.6. So 102. Still being multiplied by pi, and I haven't done anything with pi, so I'm just keeping it with them. So now I can add these together because these are like terms, okay? Because if I multiply this one out by 3.5, I'll get a decimal. If I multiply this one out by 3.1415, I'll get a decimal. I can add those together. All is well. All right, so 102 plus 56.25 gives me 158.25 pi kilometers. And surface area, so it is squared. Or I can go ahead and do that out. And let me do this problem out, and let's make sure that we get the same thing. So 158 times 3.1415 is 497,142, still kilometers squared. So now I'm going to go back up here and go to its equivalents. And if I add them up, I should get back to here. Okay, let's give this a shot. 56.25 times 3.1415 gives me 176,709. And then 102 times 3.1415 gives me 320.433. Let's add those. Oh, sorry guys. Add those up and see what we get. So plus 176.70. That's not right. Delete. 176.709. Look, I got the same answer. I'm so excited. Okay. So that's the difference in multiplying out pi or just leaving pi in there. It doesn't really affect the calculation part, but I can understand if you're a little confused about are they like terms or not. Last two. Find the surface area of the cylinder. One more time to the formula sheet. Surface area cylinder, surface, total surface area. That's what I want. Surface area of my cylinder is 2 pi RH plus 2 pi r squared. Okay. So let's see, I need a radius, I need a height. I think I'm good to go. You know, they keep trying to tell us that they're giving us diameter and doing us a favor about it. And I need a radius, so I'm just going to cut it in half. I mean, it's kind of old by now. They keep trying to fool me. They can't fool me. So my radius is 3 centimeters. My height is 10. I have all the information I need to fill in stuff, so let's do that. So 2 times pi times a radius of 3 times a height of 10 plus 2 pi times radius 3 squared. All right, let's do a little bit of cleanup. So 3 times 10 is 30, times 2 is 60. I'm going to leave it with pi. And 3 squared is 9, times 2 is 18, and I'm leaving it with pi. So I have 60 pi plus 18 pi, 78 pi. Unit of measure centimeters. I'm looking for surface area. It is squared. Or once again, I can multiply it out. It just depends on what your answer choices are. And when I do that, I get 245.037 centimeters squared, because our unit of measure hasn't changed, and it is still area. Okay. You ready for the last one? Are you ready for the last one? Okay. Now, this one about parallelograms, okay, got to remember a few things. Parallelograms, we already looked at how the the opposite sides are parallel and congruent, but we didn't really touch on remembering about the angle rules. The angle rules are this: opposite angles are congruent. Okay? So angle 2 and 4 are congruent, angle 1 and 3 are congruent. But angle 1 and angle 4 are supplementary. That means they add to 180. And angle 1 and angle 2 are supplementary. Oops. Angle 1 dies. And angle 2 are supplementary. 2 and 3 are supplementary. 3 and 4 are supplementary. Right? So let's take another look at our question. For the parallelogram below, the measure of angle 1 is 2x plus 16. The measure of angle 4 is 5x minus 11. Okay. Well, we said that angle 1 and angle 4 are supplementary. So I'm going to take what I'm given for the measure of angle 1 plus the measure of angle 4 and set it equal to 180. So 2x plus 16 plus 5x minus 11 equals 180 degrees. I'm going to combine like terms. 16 minus 11, positive 5, equals 180. I'm going to subtract 5 from both sides and get 7x equals 175. And 175 divided by 7 gives me 25. X equals 25. Well, but I was asked to find the measure of angle 2, way over here. Yay. Wait a second. I know that angle 2 and angle 4 are congruent. I can find angle 4 because I've already figured out my x. I'm just going to plug it in. So angle 4 is 5 times 25, the x we figured out, minus 11, which is going to be equal to angle 2 over here. So let's do that. 5 times 25, 125 minus 11 gives me a final answer of 114. Measure of angle 4 is 114 degrees, which is also the measure of angle 2 because these are congruent angles. So I'm going to put a box around this one because I was asked to find the measure of angle 2. I have found the measure of angle 2, and I am done, 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 done. Good luck on your finals, guys.